All right, welcome back to the deep dive.
Good to be here.
So today we're looking at something that's basically the eyes and ears of a controlled environment. We're unpacking the NTI ESTHSB sensor.
And this isn't your typical sensor.
No, not at all. Usually you picture this little black box tucked away in a server rack somewhere, right?
Blinking away in the dark. But this one's mission is different. It's not just about collecting data. It's about, well, shouting that data at you.
Making it impossible to ignore.
Exactly. It's about creating active awareness for the humans walking the floor.
And it is not subtle about it. The first thing you notice looking at the specs is this massive wall-mount LCD display.
We're talking a 2-inch character height.
2 inches, so you don't need to be standing right next to it.
No, not at all. You can be 50 feet away, glance up, and get an immediate status check. It's really designed for large spaces like warehouses or data centers.
And the specs mention it has, keyhole slots and a mounting template. Nice touches for the install, sure.
Makes life easier.
But once it's up on the wall, that high visibility is kind of pointless if the data itself isn't solid. Which brings us to the metrics.
The big three, yeah. Temperature, relative humidity, and dew point.
The temperature range is pretty serious. -4 all the way up to 185 Fahrenheit. It's clearly built for extremes.
It has to be.
Okay, but let's be honest. Dew point. Does it really deserve top billing here? I feel like most facility managers just look at the temperature and move on.
That's a common mistake.
Oh.
And a really dangerous one.
How so?
Because temperature can lie to you. You can have a room that feels cool, but is actually, saturated with moisture. Dew point is the truth teller.
So it's the point where the air stops just being cool and starts actually condensing on your equipment?
Precisely. It's the difference between cool air and wet circuit boards. If you're running sensitive electronics or storing pharmaceuticals, ignoring dew point is just waiting for corrosion to happen.
And the accuracy is tight. Just under 1 degree Fahrenheit variance and around 3% for humidity.
It's precise enough to be trusted.
Right. And in these industrial environments, trust is everything. The source material makes a big deal about the digital output signal.
Yeah, and for very good reason.
Why is that so critical?
Well, think about a factory floor. You have motors, high voltage, all sorts of electrical noise. An old analog signal cable acts like an antenna in that environment.
So a nearby motor could just cause the temperature reading to spike?
It could. You'd get ghost data.
Yeah.
But because this is a digital signal, it has a high resistance to all that noise. The numbers you see on that big screen are the real numbers.
That makes sense. And speaking of cables, the range here really surprised me. 1,000 feet on a standard C85. That's a lot of loosh.
It is. But that's not even the big story. You connect this to their EFSC fiber converter.
And the range just explodes.
It goes up to 1.2 miles.
1.2 miles. So that's 2 kilometers. You could have this sensor in a completely separate building on a campus.
Totally different use case at that point.
Okay. But I did see a little gotcha in the notes. If you're using an NTI E2D base unit.
Ah, you caught that. Good eye.
It specifically needs revision C of that unit, right? Otherwise, it's just a brick.
It's a crucial detail, yeah. Compatibility always matters just as much as capability.
So let's pull this all together. We have a sensor that's super visible, highly accurate, and can send interference-free data over a ridiculously long distance.
It basically closes the gap between the event happening and you knowing about it, no matter how far apart they are.
It really makes you rethink things. We all obsess over the thermostat setting, how hot or cold it feels.
Right. We focus on what feels comfortable to us.
But this device really shines a light on that invisible threat, the moisture.
And that raises a really interesting question for you to think about. We worry so much about how hot the air feels to our skin, but we almost completely ignore the point at which the air itself starts to weep.
What critical systems are at risk just because we're ignoring the room's sweat point? A great thought to end on. That's our deep dive. Thanks for listening.